Hello everyone, welcome to Circuit. Today we'll explore HDI PCBs, a revolutionary topic in electronics. You may wonder what an HDI PCB is and why it's important. Stay tuned, and by the end of this video, you will fully understand this cutting-edge tech powering future devices. In this video, we'll cover 4 main areas. First, we'll start with the basics, defining what an HDI PCB is and exploring its core characteristics. Then, we'll take a look at the key advantages that make HDI PCBs superior to traditional circuit boards. Next, we'll explore the wide range of applications where HDI PCBs are making a significant impact. Finally, we'll delve into the intricate world of HDI PCB design and manufacturing. Let's start with the basics. An HDI PCB, High-Density Interconnect, is an advanced printed circuit board. It enables a higher density of components and interconnections in a smaller area. This is realized through innovative design and manufacturing processes, which we'll examine closely, as shown in the images. The difference between an HDI PCB and a traditional one is obvious. The HDI board on the left is more compact with many more components. This miniaturization is vital for developing smaller, more powerful and portable electronics. One of the key features that enables this high density is the use of microvias. These are tiny holes as small as 0.05 millimeters that are laser drilled through the layers of the PCB. Unlike traditional through holes, which go all the way through the board and take up valuable space, microvias allow for connections between specific layers without penetrating the entire board. Based on the microvia concept, HDI PCBs also use blind and buried vias. Blind vias link an outer layer to one or more inner layers and end there, while buried vias are fully concealed between 2 inner layers. Using these vias, designers can route signals more effectively and create more surface space on the board for components. Besides microvias, HDI PCBs have finer traces and smaller spaces between them. Traces are the conductive pathways that carry electrical signals across the board. With HDI technology, these traces can be as narrow as 2 million Israeli new shekels, with just 2 million Israeli new shekels of space between them. This level of precision is essential for fitting the complex circuitry required by today's high-performance devices. Now that we understand the core features of HDI PCBs, let us take a look at the key advantages that these features provide. From size and weight reduction to improved performance and reliability, HDI technology offers a number of significant benefits over traditional PCBs. The most obvious advantage of HDI PCBs is their smaller size and lighter weight. By packing more components in a smaller area and reducing layer numbers, HDI boards can be 50% smaller and lighter than traditional ones. This is revolutionary for portable devices, such as smartphones, smartwatches, and drones. As every millimeter and gram matters, HDI PCBs also offer superior performance, particularly for high-speed applications. The shorter trace lengths and improved routing capabilities minimize signal loss and crosstalk, making HDI boards ideal for use in 5 grams and 6 grams communication systems, as well as other high-frequency applications. Additionally, the better distribution of copper layers helps to dissipate heat more effectively, improving overall thermal management. HDI PCBs are not only smaller and faster but also more reliable. Their microvia's robust construction and sequential lamination process enhance resistance to thermal cycling and vibration stresses. This greater durability leads to lower failure rates, even in harsh aerospace, automotive, and other critical application environments. Given their many advantages, it is not surprising that HDI PCBs are being used in a wide variety of applications, from daily used consumer electronics to advanced medical devices and aerospace systems. HDI technology is driving innovation across industries. The consumer electronics industry widely uses HDI PCBs. When using smartphones, tablets, smartwatches, or laptops, you are using devices relying on HDI technology for compact size, high performance, and long battery life. As devices become smaller and more feature-rich, the demand for HDI PCBs will keep rising. The automotive industry also benefits greatly from HDI PCB technology. With cars getting smarter and more electric, there's a soaring demand for compact, high-performance, and reliable electronic components. HDI PCBs are used in advanced driver assistance systems, ADAS such as radar and cameras, as well as the battery management systems, BMS of electric vehicles. In the medical field, HDI PCBs are enabling the development of smaller, more precise, and more reliable medical devices. From implantable devices like pacemakers to minimally invasive surgical tools and advanced diagnostic equipment, HDI technology is helping to improve patient outcomes and revolutionize healthcare. Now that we've explored the what and why of HDI PCBs, let us take a brief look at the how. Designing and manufacturing HDI PCBs is a complex and precise process that requires a combination of advanced engineering, specialized equipment, and strict quality control. One of the most critical aspects of HDI PCB design is the stack-up design. This refers to the arrangement of the various layers signal, power, ground that make up the board. Common HDI stack-up structures include 1 plus N plus 1, 2 plus N plus 2, and ELIC. The choice of stack-up has a significant impact on signal integrity, thermal performance, and overall cost, so it's a decision that must be made carefully. As we mentioned earlier, laser drilling is a key manufacturing process for HDI PCBs. Unlike mechanical drilling, which is limited by the size of the drill bit, laser drilling can create microvias as small as 0.05 mm with incredible precision. This process is essential for creating the blind and buried vias that are characteristic of HDI boards. Another critical manufacturing process is sequential lamination. Instead of laminating all the layers of the board at once, as is done with traditional PCBs, sequential lamination builds the board up one layer at a time. This allows for the creation of complex blind and buried via structures, and ensures better registration between layers. That is the end of our HDI PCB introduction. We hope this video was useful. If you have questions, leave them in the comments. Subscribe to our channel for more electronics manufacturing content. Thanks for watching.